All right, in this video, I'm going to show you the solution for the example that you just tried on your own. So in this example, it's asking you to find the measure of angle X and the measure of angle Y. So what I'm going to do is I'm going to have to use the trig inverse. Let's find angle X first. I'm going to circle that X, that's my reference angle. I'm going to stick with tan since we used that first last time. Let's label our sides here. This would be opposite, this would be adjacent, this would be hypotenuse. So if I'm setting up tan, I would have tan X equals the opposite leg 8 over the adjacent leg 15. All right, from here I need to solve for X, get X by itself, and I need to untan this side. In order to do that, I'm going to use tan inverse. What happens here is the tan inverse cancels the tan, it leaves me with just X. On the other side I have tan inverse 8 over 15. I'm going to plug tan inverse 8 over 15 in my calculator. That gives me an angle measure of 28.1 degrees. That is the measure of angle X. Now let's find angle Y. So I'm going to circle Y. That changes my reference angle, which changes the sides. This would now be opposite and this would be adjacent. Let's use a different trig function because I have all three. Let's use sine. So I'm going to set up sine here. Sine Y equals opposite, which is 15 over 17, which is the hypotenuse. Just like I did tan inverse to untan X, I'm going to do sine inverse to unsine Y. So let's take the sine inverse of both sides. That will essentially cancel the sine, leaving me with Y. On the other side, I have sine inverse 15 over 17. I'm going to plug that in my calculator. And that gives me 61.9 degrees. And that is the measure of angle Y. As a quick check, the two acute angles in a right triangle should always be complementary. They should add up to 90 degrees. So if you look in this example, I have angle Y is 61.9 and angle X is 28.1, and that does add up to 90.